Hey everyone, it's Mrs. Brimlow, and today we're going to take a look at systems of equations. So please make sure you have your RICAS review packet out and you copy down the examples as I go through it. So in 8th grade, the focus is on systems of linear equations and just 2 of those equations. You can look at more than 2 equations at one time. You can also look at different types. And if you're in algebra, you may have looked at those quadratics, absolute value. But for our purposes in this video and in prepping for RICAS, we're going to focus on 2 linear equations that we're comparing in a set of systems. So when we are looking at systems of equations, there are 3 possible solutions. One solution, meaning the lines intersect at one point and share one common ordered pair. It could have no solution, where the lines are parallel and they have no common solution or ordered pair. And then infinite solution is where the lines overlap one another and share every ordered pair together. They're the same thing. When you're looking at the equations, you can also tell how many solutions they'll have from the equations. So when you're looking at one solution, you won't have the same numbers. So 2x and 5x, they aren't the same coefficients. And then I have -3, +3. Even though they're both 3, they have different signs. Those are not the same. When we have no solution, what you'll find is that it has the same, it will have the same coefficient for x and y. Now, as I look at it right now, it doesn't, but I can change it so it does have the same. What I can do is multiply this top one by -2. So I'd get -2x, and I'm multiplying the whole thing by -2 to keep it equivalent. And that would be -6y equals to -10. So notice that -2x and -6y are the same. In slope-intercept form, they'd have the same slope, but these numbers over here are different, and they would end up being our y-intercept. So that would be no solution. And then for infinite solutions, what you might guess is that they are completely the same. So once again, if I multiply this by -4, -4 times 0.25 is -1, or -x. -4 times -0.5 is +2y. -4 times 1 is -4. These are the exact same equation when multiplied. Same thing in slope-intercept form. It would be the exact same thing, okay? When you're solving systems of equations, you have 3 different methods. You have the graphing method, you have the elimination method, which is in this box right here, and then you have substitution, okay? I'm going to do this out, and then we're going to do the you try together. So in substitution, you're replacing one thing with something else. So in this case, notice that we have one equation in standard form and one in slope-intercept form. The best time to use substitution is if your system looks like this, where you have one equation solved for one of your variables. So what we're going to do is we're going to replace what y equals to, 3x minus 3, into the other equation. So if I rewrote this, it would look like 2x plus 5, and then I'm going to multiply that by, once again, replacement, 3x minus 3 equals to, finishing out the equation, 19. So this equation is exactly the same. The only thing I've done is replaced y with what it equals, 3x minus 3. And now I can solve this because I only have one variable. I can only solve for one variable at a time, which is x. So I'm going to keep the 2x for now. I'm going to distribute the 5, so I get 15x minus 15 equals to 19. I'm going to combine like terms. Now it's a 2-step, so I'm going to add 15 to both sides. 17x equals 34. Divide by 17, and x equals 2. Because I was able to get an x value, that means I have to find a y value. There is a solution. So I'm going to take this 2, and I'm going to substitute it into either equation to solve for y. It doesn't matter which, because they share it in common. I'm going to use the bottom one, though, because it tells me exactly what to do. It says to do 3 times x, which is 2, so 3 times 2, which is 6, and then minus 3, which is 3. So my ordered pair, or where these 2 lines intersect, would be at the point 2, 3. Okay? So you can use whatever method you want when you're solving systems. It just depends on the problem, what method is going to be better. I will say that on RICAS, if they don't give you a graph, I don't know that you're going to have graph paper, so you're going to need to know and be comfortable with using either elimination or substitution, or both is best, of course, but you should be comfortable with one method. So we're going to do this word problem together, and then you're going to practice. So Sylvie and Leah are going shopping. Sylvie spent $120 on 3 pairs of jeans and 6 blouses. Leah spent $90 on 2 pairs of jeans and 5 blouses. What is the cost for 1 pair of jeans and 1 blouse? So I'm going to say X equals the cost of jeans, Y equals cost of blouse. So I'm going to write some equations. First, I'm going to write Sylvie's. So she buys 3 pairs of jeans and 6 blouses for a total of $120. Leah buys 2 pairs of jeans and 5 blouses for $90. So based on how these two equations are set up, they're both in standard form, so I would use elimination. That's my preferred method, and in this case, it makes the most sense. You could change one of these to solve for either X or Y. It wouldn't be simple since all of them, X's and Y's, have coefficients that aren't 1, but that's a personal preference. I'm going to solve this using elimination. So in the elimination method, the word eliminate means to get rid of. So we want to get rid of either X or Y when we combine the equations. That means that their coefficients have to be opposite. So I have 3 and 2, 6 and 5. So that's not happening as it is. What we can do, and as we saw in looking at the different solutions, is multiply the equations by a number. So that they have the same number but different signs, so opposite coefficients. Doesn't matter in this case. You're gonna have to multiply both equations by something. So you could either try to eliminate X or Y. I'm gonna go with X because they're smaller numbers, so it'll be a little bit easier to work with. When you go to take RICAS, some of these problems will let you use a calculator, some of them won't. So always try to work with the smaller numbers. So I'm going to change these equations so that my X has a coefficient of 6 and -6. Doesn't matter which one you make negative. I'm going to multiply the top one by a negative number. So I'm going to multiply the top by -2, and then I'm going to multiply the bottom equation by 3. Once again, doesn't really matter which one's negative. So when I do that, I have to distribute this to every part of the equation to keep it equivalent. So this is going to become -6 minus 12y equals -240. And same thing here, when I distribute that 3, it's going to be positive 6x plus 15y equals to 270. You also have to do it to this number at the end as well. So now, if I was to combine these equations together, X is going to zero out. They're opposites, okay? So now I can solve for Y. -12y plus 15y is 3y. -240 plus 270 is 30. Divide by 3, and Y equals 10. So each blouse costs $10. Now I have to figure out how much each pair of jeans costs. So similar to substitution for step 2, I'm going to plug this or substitute this value for Y into one of the two equations. It doesn't matter which equation you use. You could even use one of the new equations if you wanted to. I would go with this equation here because the numbers are the smallest and they're all positive. So we're going to keep X because we don't know what it is yet. And all I'm going to do is replace Y with 10 because that's our solution for Y. So now the only variable I have to solve for in this equation is X. So 2X plus 50 equals 90. I'm going to subtract 50 from both sides. So 2X equals 40. Divide by 2. And X equals 20. Okay, so the ordered pair that represents the solution for this problem is 2010, and what it means is that each pair of jeans costs $20 and each blouse costs $10. Okay. So make sure you have all